Hello, class. I wanted to do a demonstration of a lab and kind of walk through how I would go about solving it, just to give you some ideas and maybe give you a different thought process of how to attack a problem with a lot of little requirements. So, if you haven't already noticed and you're looking for some additional practice, down towards the bottom of our textbook, there are sections called additional labs. And there are lots of different labs available for different things in different categories. So you can jump into some of these and take a look at different examples. And if you want to try a different lab, you certainly can to get some more practice. So some of them are kind of interesting, some of them are kind of mundane, but regardless, the practice is what makes you a better programmer. Just keep trying out different things. So what we're going to do today is we're going to look in chapter 30, and we're going to look at a particular lab, and we're going to look at the bank account class lab. Now this is a lab that, let me open it, and it's asking us to build the class part of this project. So we're going to have a main program, and we're going to have a class. And from that class, we're going to make some objects, and the objects, of course, will be made in the main program. So you can see it gives us a lab program, and we have a bank account class, which we're going to create. And if you look at it, it looks like it has a name and two kind of amounts. It looks like we have some checking account balances and some savings account balances, and these are all the methods that we're going to have to build for the program to work right. So in this particular lab, they're giving us the program. We have to write the object or the class so the objects can be made so the program works properly. So if we take a look at our description, it tells us in the bankaccount.java file, build a class called BankAccount that manages checking and savings accounts. The class has three private member fields: the name, the savings account, and the checking account. So it's telling us what we need for our field. It's telling us the name of the class. So we can start thinking about it now before we even write any code, that we're going to need three private fields. We're going to need a constructor. We're probably going to need set and get methods for each of those. And sure enough, if we look down here at the requirements, we see here's our constructor, the first bullet point. We have our set and get for the name, our set and get for the checking account balance, and we have our set and get for the savings balance. Now, it looks like these are a lot of requirements, but on the surface, if you look at it, the first bullet point is a constructor, and it just sets values. And then we have our gets and sets, which don't really have any of the logic in there other than assigning a value or returning a value. So while there are a lot of methods out there, they're pretty easy to implement. And then we have some logic here. We have a deposit into checking and a deposit into savings, which takes a parameter of an amount and adds it to the checking balance only if it's positive, and for the savings, add a parameter amount to the savings account balance, again only if it's positive. So that tells us we need to have a little logic in there to check the amount to make sure it is a positive amount before we add it to the balance. And we can take a peek down here and take a look, and they're not trying to trick us with any negative amounts, but we may try to add that in later just to see what happens. Because in their test bench, what they call the test bench, they may have different scenarios where they throw in negative amounts, and we're going to have to see what happens. Then we have, conversely, instead of deposits, we have withdrawal from checkings, again, only if it's positive. Withdrawal from savings, also if it's positive. And we have a transfer to checking, so we can take an amount and subtract it from the savings account and add it to the checking account. So we have a few methods to write. So let's start building out our bankaccount.java, and it gave us the template, so we can start working on that. And I'll scroll down a little bit, and we can start with our public class definition. Public class bank account, and we want to use our curly brackets. And first thing we're going to want to add is our private fields. And this is where we have some leeway. You can see in the main program, it's telling us what the methods are and what we have to name the methods for it to work. But it doesn't say how we have to name the variables on the inside, which is the beauty of classes and objects. You can create the class and implement it any way you want, as long as the functionality does what we need it to do. So we'll call it pretty standard names. We're going to give it private string, and we'll call it, well, we just call it name. It's pretty straightforward. And we'll have a private double, because it's a dollar amount, so we'll use doubles. And we can call it checking balance. And we can have another private double savings balance. Now, if we go back, and it's always good to go back and check your requirements as you're writing the code to make sure you're answering the question they want you to answer. We have a customer name, we have a balance for savings, and a balance for checking. Now, I put them in a slightly different order. I put checking first and savings second. Doesn't matter. They're just variables that the objects are going to use. So that's fine. Next thing we should make is a constructor. And I will cheat a little bit, and we can copy this if we want. And we can use what they're giving us, and we can paste it in, and there's our constructor's method signature. Now, we don't have to do that. We can certainly type our own new ones in, and I, out of habit, I'm going to add my P underscore in front of it. So I know in the code it's a parameter. Don't need to do that. Like I said in other videos, this is how I write the code, and this is something I've always done, and it helps me keep things organized. So in a constructor, we know we have to assign the values from the constructor's parameters into the object's fields. So it's simply an action of doing name equals P underscore new name. And we can do checking balance equals P underscore CH balance. And we can do another one of savings balance equals P underscore S balance. And we have now created our, our constructor to have what we need. Now, we can use the this operator if we needed to. We can put in this to actually call out that we're using the objects variables. So we can use this if we need to. We don't necessarily need to in this particular case, but I'll put it in there just for completeness, just so we have it in there. Now, we still can't run our code. We can try, but since none of these methods have been created yet, it will certainly fail. So we'll give it a try just to confirm that and see what kind of errors we get. And oh boy, lots of errors. A method not found, cannot find symbol, method not found. So you could see, yeah, we can't even test this out yet. So let's start writing our getters and setters. And we can start with, well, let's just go down the list. Let's go down our class definition. And we can do let's do the getters first. They're easiest. Public string. So what do we, if the string is the only one we have as a string is name, get name. And we don't need a parameter for getter, but we do need to return name. That's it. That's all we need for that one method. Very simple. We do need to do the checking and savings balance. But now we need to be careful. We do need to be careful here because they're telling us in their code what methods we need to use. So we need to use these exact phrases, otherwise it won't work. So we need to match that up. So let's just make sure that get name was correct. It was get name. So we do want to use a get checking balance and a get savings balance, just as they're written here. So I'm going to copy the text just so I have it. Copy and paste is your friend sometimes, so you don't have to worry about making a typo. So public double, and I'll paste now, get check balance, and we are going to return checking balance. And we will do the same thing for savings. And again, no parameters, and we return savings balance. So let's just double check, make sure we have the savings balance right. Get save balance, get save balance, and that's what I have. So we have our 3 getters written. So now let's write our 3 setters and get that created. Now you can either do them right after each other. You can do a get and a set, or you can do all your gets and all your sets. Again, personal preference, pick which one you like the most. I kind of like to keep them grouped together. Just makes it easier to find things. So I'm going to do my setter right here. Public void, because remember, setters don't return anything. Set name. And now we'd have to give it a parameter. New name. Call it new name. We could call it p name again too if we wanted to. That would be perfectly fine. But we can just do that. And now we just set name equals p underscore new name. Very similar to our constructor. In fact, it's exactly the same kind of assignment as our instructor. So we have our gets and our sets. Oops, so that space there. And now we'll just continue with the sets for the others. Public void set check balance. And we do a this dot, and what did I call it? I called it checking balance. This dot checking balance equals, well, we need a parameter here, double balance. Or we can call it amount. I think they used amount a lot in the p underscore. They called it amount right up here. So yeah, so we'll call it amount, just like they did. Like they put it in the directions. So we have our p amount, and then we do p underscore amt. And we'll do the same thing for savings, public void set save balance, double p underscore amount. And then we do our this dot savings balance equals p underscore amount. Very simple. We created our getters and setters. Those should be pretty straightforward. I think in another video next week, I will demonstrate a different kind of IDE, a development environment, something that's not Zybooks. And I'll show you that they have built-in functionality that builds these getters and setters for us, so we don't have to do all this manual effort. So that's some of the other benefits of using different IDEs, is you get a lot more tools at your disposal to help you write code, instead of having to type all these lines of code manually. Okay, so we have our gets and we have our sets. So the next one we want to write is deposit the checking. And we're going to copy the method signature, and then we're going to go build it down below. Now, what do we need to do here? We need to take this amount and we need to add it to the checking account balance, but only if it's positive. Only if it's positive. So, how do we check to see if something is positive? Well, if P amount is greater than 0 for positive, I mean, I guess conceptually we could do greater or equal to 0. So if we added a 0 amount to your checking amount, it'd still be the same amount. I'll leave it as just strictly greater than at this time for positive. So if it's greater than 0, so we do checking balance equals checking balance plus P underscore amount. Do we need to do anything if it's less than 0 or negative? Maybe we should print a message. Maybe we should print a warning. We're going to leave it as is for now because, well, the requirements didn't say what we had to do for a negative number. So we're just going to do the positive side. We're going to build out the remaining 4 of these, and then we're going to try it out and see what kind of errors we get. So always assume there's going to be errors when you run your code. This is a lot more code than I like to write in any one shot without testing. So what we could do is we could write smaller pieces and then update our lab program, but we can't modify our lab program. It's written as read-only. So we're kind of stuck into having to write all the different methods at once. Like I said, in another video, I'll show some other examples of how we can do some practicing and just what they call stubbing out methods, where you write the method signature and that's it. You don't write any code for it. This way, it's a placeholder and your code will compile. But we'll look at that at another time. So let's go through and write the rest of these methods, and then we can try testing our code. So we're going to do the same thing for savings. I'm going to cheat a little bit and do a little copy and pasting here. So if you do want to do the copy paste method, just go line by line. Make sure you change everything that you need to change. Otherwise, you're going to have some weird functionality if you leave checking and savings in the wrong spot. And it's not a capital; it's a lowercase. And we'll do the same thing over here with savings balance. Everything else should be fine. Next, we're going to do, we just do our deposits. Let's do our withdrawals. Public void withdraw checking. And again, P underscore amount. And again, if P underscore amount is greater than 0, then, well, this time we do checking balance. Well, we could use a different kind of syntax. We could do minus equals this time. So instead of doing equals something plus something or equals something plus minus something, we can use this minus equal shortcut method. And this is basically the same as writing, this is the same as checking balance equals checking balance minus P underscore amount. It's just a shortcut method, and I think we talked about that earlier. But I just wanted to throw it in for a little difference to mix things up. And now we, oops, I spelled checking wrong, I just saw that. Public void withdraw savings, and I still spelled checking wrong, I just saw it again. Double P underscore amount. And if, again, P underscore amount is greater than 0, then we can do savings balance minus equals P underscore amount. And I think we have one more to write, a transfer method. I'll just copy and paste this one. And this is going to transfer a balance from savings to checking, I think it was. Savings account and add to checking. So if we build this one, we're just going to have 2 steps in here. If P underscore amount is greater than 0, we then do checking balance. So we're taking from savings and we're adding to checking. So checking gets added first. And savings balance minus equals P underscore amount. Now, one thing I probably would have added if this is a more realistic program would be to make sure that the amount that you're transferring out of checking, out of savings is a valid amount. Meaning if you have $100 in your savings account, you can't transfer $200 from savings to checking. But I don't think in this example it really matters for what they want to do. So we have all our code written. I'm sure there's a hidden typo or two in there somewhere. So let's bring this up again and take a look at our lab program and see if we can get this to do our account transactions, get a name, and print a checking and savings balance. Let's see what happens. Oh, and there's the first error. Bank account Java line 56. Apparently I don't know how to type double, so I'm going to line 56 and I will fix that. There we go. And we'll run it again. Oh, okay, only that one error. That was interesting. So is that the right amount? So we're starting with a checking of 500 and a savings of 500. We withdraw 100 from savings. So just, thinking, writing it down on a piece of paper or whatever, checking is 500, savings is now 400. If we withdraw 100 from checking, again, they're both 400. And then if we transfer to checking, the $300, checking becomes 700 and savings becomes 100. So great, it looks like we have the right answers. So that being said, let's run it against the test cases that they give us and see if they throw us any curveballs. It'll just take a couple seconds here to run through all the tests. Maybe a few seconds more. Oh, look at that. Got lucky on the first try, 10 out of 10. Sometimes that happens, usually not, and we have to go back and fix things, and that's fine. But you'll see now it'll give us the answers to the test and what it was looking for and what it was trying to do. You'll see here it had some different amounts, more different amounts. Oh, look, it tried to throw us a curveball here on test number 4 with some negative numbers. So that's good. So we passed that test. So they tried to trick us. Great. Just for fun, let's try this. Let's change this. Oh, I can't change this. I wanted to see what would happen if I changed this to a number that was more than available, but I don't think we can do that. I don't think we can change this program. No, I can't edit. Okay. Okay, I guess that's it. Like I said, I wanted to show you how I would walk through it. There are some other practice ones if you want to try. And maybe in another video I'll come through and I'll do one of these. Maybe I'll do this one next in another video, self-pay kiosk. So this one's interesting. You'll see that it has an asterisk next to the title, lab asterisk. That means it's a larger program. And the larger programs, well, they're larger and there's more work involved, but what they do is they break it up into pieces. Like you'll do one step at a time. You'll get step 0. I don't know why they started 0, other than computers start counting at 0. But you'll do step 0, you'll do the initial setup here in the specifications, and then you'll do step 0, and you'll do all that. And then after you complete step 0, you'll run it and submit for grading. And at some point, you'll get whatever the points required for step 0 are. Looks like there's no points here, but you'll get a successful test for that, but all these other ones will fail. And the goal is to complete step 0, get all the points, get step 1 done, then get all the points, and just as you finish one step, move on to the next. So that's a form of incremental development, and we'll take a look at this lab next. But for tonight, I just wanted to work on that, at least that one lab, give you some ideas. As we get into the remainder of the semester, we'll be looking at more of problem-solving kind of methods and more practice. So a lot of practice coming up. Okay, that's it for tonight. Have any questions, reach out, and I'll see you in the next one.